see, we have capacitor, so we know the energy is half cv square and or q square by 2c. Half of the energy will be stored in the capacitor, half of the energy will be lost, dissipated. So half energy is dissipated, half energy is stored in the capacitor. So this is one thing. Another thing is that suppose I am charging this capacitor C1, this is capacitor C1 up to voltage V1, and I am charging capacitor C2 up to voltage V2. Then I am connecting both capacitor, and this is plus to plus and minus to minus. So in that situation we need to find out common potential. So what is common potential? Simply this is C1 V1 plus C2 V2 divided by C1 plus C2. Now what we are doing, again we are doing the same thing. We are charging the capacitor C1 to the voltage V1, and we are charging again the C2 to the voltage V2, but we are connecting this plus with minus and this minus with plus. So polarity is very important during application of all this formula. So in this situation V common will be, in this situation V common will be C1 V1 minus C2 V2 divided by C1 plus C2. So here I am using plus sign, here I am using minus sign. So from this relation you can find out the common potential easily if you know this concept. Another thing is that suppose we are charging this capacitor C1 up to voltage V1, and we have not connected C2 capacitor with any battery. So we have not connected capacitor C2 with any battery. So in this situation you have to take care that this is what. So we have not connected C2 with any battery V2, so this their voltage you need to assume 0. So you are assuming that their voltage 0. In the situation if you want to find out common potential, so what will be common potential then? C1 V1 divided by C1 plus C2. So here actually the term of C2 into 0 will be eliminated from here, so no need to worry about that. We have not connected C2 capacitor with any battery, then what to rate voltage about it, rate voltage across it is 0. Suppose we have not connected capacitor C1 with any battery, and we connected capacitor 2 with the battery charged up to the voltage B. So you no need to take C1. Okay, C1 will be 0. Okay, and you need to multiply C2 into B divided by C1 plus C2. This concept is very important. So once you know common potential, it will solve your many issues. So we are connecting this C1 of voltage V1, and we are connecting C2 voltage of V2. So we need to find out the energy loss during this process. So I already told you what is energy loss. Okay, so that is Q into V. So from there you can find out energy, total energy, and half of the energy will be stored in the capacitor, half of the energy will be dissipated. So here I want to find out energy loss. So energy loss is here. So energy loss is 1 by 2 C1 C2 divided by C1 plus 2 V1 minus V2 whole square. But here we are applying this formula when this plus of is connected to plus, minus is connected to minus. But if in place of this, if you are connecting this capacitor plus and minus, this is C1 V1, and we are connecting this capacitor to this like this. This is C2 V2, and this is minus plus. So in this situation energy loss will be, in this situation I am writing here, so energy loss, in this situation energy loss will be 1 by 2 C1 C2 divided by C1 plus C2, and then it will be V1 plus V2 of whole square. So this is very important relations when we are connecting both capacitor with the plus with the minus, minus with the plus. In this situation energy loss is 1 by 2 C1 C2 divided by C1 plus C2 V1 plus V2 whole square, and we are connecting plus plus minus minus. In this situation 1 by 2 C1 C2 by C1 plus C2 V1 minus V2 whole square. So this is the energy loss of the capacitor. You need to take care of this relation. Now we want to know about charging of capacitor. So basically we are charging the capacitor. So this is battery capacitor. We connected this with, okay, so we take one resistance in the circuit. So basically one resistance we have in the circuit, and then we connected with the battery here, and then so we are charging it. So this is resistance is R, and this resistance capacitor is C. So we also this is, so say it as RC circuit. RC circuit, basically this is the resistance of the load. So voltage across the resistance will be R, voltage across capacitance will be C, voltage across the source will be V. So you can write from here V will be equal to what? VR plus of VC. So you know VR is what? I into R, and what is VC? You know from here Q equal to C into V. So Q charge is stored, so C into V. If you know Q value of Q, so this will be Q divided by C. If you differentiate this, you can also say rate of change of voltage. Rate of change of voltage dV by dt is equal to dq by dt divided by c. So from here also you can say rate of change of voltage with respect to time is equal to I by c. Or from here you can also say I is what? C dV by dt. So we also say this is a displacement current. Displacement current is C dV by dt. So another relation is what? Main relation is what? Q equal to Q naught 1 minus E minus T by tau. So here tau is what? R into C. So R into C, this is known as time constant. Okay, we are multiplying resistance with the capacitor. This is time constant. So this carries the unit of time. So tau is RC. This is time constant. Q equal to Q naught 1 minus E to my power minus T by tau. Basically if I put this will give the charge at any time charging, okay, on capacitor. At any time, what is the charge on the capacitor when you are charging? This relation Q equal to Q naught 1 minus T by tau. Tau is R into C. This relation is very very important. So if I put at t equal to 0, if I put t equal to 0, if you put t equal to 0, so this will be e power 0, so this will be 1. So I will write Q equal to Q naught 1 minus e power 0. So this is what? Q naught, and 1 minus 1, this is 0, this is what? 0. But at, if I will put t equals to infinity, so t equal to infinity, Q equal to Q naught 1 minus e power minus of infinity. So e power minus infinity is basically what? 1 by e to the power infinity, 1 by e to the power infinity, 1 by infinity. So 1 by infinity, it will be 0. So if you solve it, it will be Q naught. Means at t equals to 0, charge 0. At t equals to infinity, charge is Q naught. Means to full charge, okay, the capacitor up to the maximum value of Q naught, it will take long time. Means that we say here it has infinitive time, t equals to infinitive mathematically. So if you understood this relation, it will help you a lot. Okay, so now we'll draw the graph of charging. So basically what you are doing, you are charging the capacitor. You are charging the capacitor. So you are charging the capacitor. So this is basically, if I say this is current and this is time, okay, and this is current, this is time. So what do we say? This will charge like this, okay, charging will be like this, and it will take 63 point, okay, so this is the charging. Okay, so basically the charging is basically happening through the exponential curve. Charging is exponential happening through the exponential curve here. So what we can say, if you put at any value of t equals to t, so we can find out, okay, that value of charging. So what I want to say, if I put a t equals to t, suppose if I put t equals to tau, so what is coming? T equals to tau, so basically RC time. At RC time, what is coming here? Q equal to Q naught 1 minus e power, it will come minus of 1. So if you solve it, Q naught 1 minus 1 by e. If you solve it, it will come something 0.63% of Q naught. Okay, so at this time, it will be charged up to, 63.7%. okay, so to charge the capacitor to 63.7%, okay, or 0.63 point of Q naught, it will take t equals to tau time. Clear? So this is one thing. Another thing is what? This is Q equals to, see, Q equal to Q naught 1 minus e power minus t by tau. If I differentiate this both sides, so dq by dt equal to d dt, and multiply by q naught. Q naught minus q naught e to the power minus t by tau. Q naught is constant because it's maximum value, so it will be 0. dq by dt is our current at any time t equal to this will be 0, so this is minus q naught and minus 1 by tau, so take outside minus 1 by tau, it will be outside, and this is e to the power minus t by tau, so e to the power minus t by tau, and then again t, it will be 1. So basically what we say this as I equal to q naught by tau and e to the power minus t by tau. So the q naught by tau is basically we replace it as I naught, suppose. So basically I equals to I naught e to the power minus t by tau. So this is the charging current in the capacitor. This is the charging current in the capacitor. Okay. So this is the charging current in the capacitor. Charging current in capacitor. This is charging current in the capacitor. So in charging current, if you put t equals to 0 and t equals to infinity, you can observe what is happening over here. So in charging of the capacitor in this current here, if you put t equal to 0, so what is coming? I equal to I naught e to the power minus of 0, it will be whole 0, so I is I naught. Okay. So at t equal to 0 you will get current. Okay. At t equals to 0 you will get current. It means it will behave like closed circuit. It will behave like closed circuit. At is behave like closed circuit. The capacitor at t equals to 0, capacitor from the starting of the circuit at t equals to 0, it behave like closed circuit, means there will be current in the circuit. But what if I put here t equals to infinity? So t equals to infinity, put in the relation, so I equal to I naught e to the power minus infinity. So this will 1 by e to the power of c, I naught into 1 by e to the power infinity. So this is 1 by infinity, I naught into 1 by infinity. So this will be what? 0. Means at t equal to infinity current will be 0. At t equal to infinity current will be 0. So means what? At t equal to infinity means at after long time, at t equals to after long time, at t equals to infinity, it will behave like open circuit. Okay. So capacitor behaves like open circuit after long time when you take t equals to infinity time. So what I'm saying, so I'm writing here, so it is now open circuit. This is now open circuit. This is very important. Okay. The application always comes okay in your paper, so you need to take care of this relation. So first I am doing discharging of capacitor, then I will take numericals on it. So discharging of capacitor, so basically you say q equal to q naught e to the power minus t by tau. So this, by using this relation you can give the discharging of the capacitor. Here tau is equal to r into c, this is known as time constant. So q equals to q naught e to the power minus t by tau. So this is the thing. Here if you differentiate this, so here if you differentiate this, you will get the same relation, so no need to differentiate this right now. So what I am saying, during discharging, if I put t equal to 0, so what's happening? At t equal to 0, so if you put t equals to 0, it will be 1, so q is q naught. So during discharging at t equals to 0, it is maximum. It is maximum. And at t equal to infinity, if I put t equals to infinity in this, t equal to infinity, so it will be what? E power minus infinity, 1 by infinity, so it will be 0. So at t equal to infinity, it is completely discharged. But what if I put t equals to tau? T equals to tau. If I put t equals to tau, so q is what? Q naught e to the power minus ka tau divided by tau. So this is what? Q naught, and this is, if you solve it, it will come 1 q naught by e. If you solve it, it will come 0.37% of q naught. Means after t equals to tau time, after t equals to tau time, it will be you are going to be Rankar. So what I am saying, if you draw this graph, so this is q and this is t, so this graph is exponentially decrease because it's a discharging, so it will exponentially decrease. And okay, at t equals to tau, at t equal to tau, at t equal to tau time, okay, it will be 0.37. So you need to remember this relation in your brain. So now you understood about how when capacitor will be open circuit, when capacitor will be closed circuit, and charging of capacitor, discharging of capacitor. Now we are going to understand the numericals based on this concept. here it is 20 volt. So question is asking you the current. Okay, question is asking you the current across AB. Okay, in AB this is C D at t equal to 0. At t equal to 0, question is asking you the current. At t equal to 0, question is asking you the current. So see, at t equal to 0, at t equal to 0, it will behave like short circuit. It will be closed circuit. You can remove this. So basically you need to know how to redraw the diagram. So now this diagram becomes like this. This is resistor and there is nothing is. It is just okay open here. Okay, at t equals to 0. Wait. Okay, mm, here. So see, this question I have to change the question, but what I am saying, if I have to solve this question, how I will solve. So at t equal to 0, at t equal to 0, at t equal to 0, so it will be what? It will be closed circuit. Okay, so it will be closed circuit means short circuit. At equal to t equal to 0, it will be closed circuit, short circuit. So basically what will happen now, the current will not pass through it. Okay, current will go through this. Okay, so this is short circuit. Okay, this is sort of all current will bypass through this. If you measure the current here, so current, if you put here ammeter, so here current will be 0. Here current will be 0. So this question also I can ask that if I put ammeter over here, so we will get no reading at t equal to 0, at t equal to 0 here. Okay, so this is the thing. But what about if I will ask you at t equals to infinity, after long time t equals to infinity, in the circuit what will be current across AB? So in this situation this will be open now. This will be open now at t equals to infinity. Capacitor will open. So now this circuit will be like this. So now this capacitor will be like this. This is 20 volt and this is given 2 ohm. This is given 2 ohm. So this is given 2 ohm. So now this is 2 ohm. Okay, so what is now, so we want to find out current. There is no use of this capacitor now. It is open circuit now. So you can apply V equal to IR. So I across AB equal to 20 divided by 2. It is 10 ampere. 10 ampere. This is 20 volt, this is 2 microfarad, and this is 2 ohm, and this is 2 ohm. So question is asking you the current across AB and CD. So basically what you need to find out, current across AB and current across CD at t equal to 0, at t equal to infinity, at t equal to 0 and t equal to infinity. So at t equal to 0, this will be short circuit. Okay, this will be closed circuit. Okay, so you can rewrite this diagram now. This diagram will be something like this. So this will be okay, closed circuit now, and this is resistor here, this is resistor here, and this is, so this is, you see 2 and 2, this is parallel combination. So again you can redraw this. So this will be equivalent to, this will be equivalent to now 1 ohm capacitor, 1 ohm capacitor. So if you know how to redraw, you can solve any questions. Okay, so this is for 20 volt and this is for 20 volt. This is 1 ohm. So what is current across it? Current across it is 20 by 1. So 20 by 1 is 20 ampere current. So this 20 ampere current will not pass through either this or this. Basically this 20 ampere current is total current here. 20 ampere current is total current here. Now this 20 ampere current will okay distribute over here. Because the resistance is equal, so current will pass equally, go equally, distribute equally through both the resistors. So here current will be, if you put ammeter, 10 ampere across it and 10 ampere across it. So if you know how to apply the concept, you can okay, you can know drawing the circuit. You can draw any circuit, but for that you have to know the concept. So in this situation, at t equals to 0, at t equals to 0, at t equals to 0, uh, um, uh, we need to find out current. Suppose this is A, this is B, this is C, this is D, and this is E. This is E. So we need to find out at t equals to 0 current across BC, current across BC, current across BC. Okay, and at t equals to 0 we need to find out current across BC, and at t equals to infinity also we need to find out current across BC. At t equals to infinity, at t equal to infinity we need to find out current across BC, and at t equals to infinity, at t equals to infinity we need to find out the voltage across capacitor. Okay, so voltage across capacitor, voltage across capacitor. So if you understood this question, you can solve anything. Okay, so you have to apply all the concept over here. So basically, starting from t equals to 0, so at t equal to 0, so at t equal to 0, what will happen? This will be what? This will be what? Closed circuit. So I'm not only drawing diagram now, and I'm solving directly. So this will be closed circuit now. So this 2 ohm to ohm is parallel. So 2 ohm to ohm parallel, so equivalent will be 1 ohm, equivalent will be 1 ohm, and 1 ohm is connected in series with 2. So this will be 3 ohm. R equivalent will be 3 ohm. So from here you can find out current will be 40 by 3 ampere. So this 40 by 3 ampere current will pass through it. So if I will ask you current across AB, so 40 by 3 ampere, current across AB 40 by 3 ampere, current across AB it will be 40 by 3 ampere. And because it is now at t equals to 0, it is what? It is closed circuit. So current will distribute across it and across it. So 20 by 3, so if you divide 40 by 3 by 2 parts, it will be, because 2 ohms, so I am directly dividing 20 by 3 ampere current across it and 20 by 3 ampere of current across it. At t equals to infinity, if I want to find out current, so I am erasing this now. So at t equal to infinity, this will be what? This will be what? Open circuit. At t equal to infinity, capacitor will be open circuit. So now you have to redraw the diagram. So at t equal to infinity, what will happen? So there will be, this is on now resistor only, and this is open now. This is open now, and this is battery here, and this is 40 volt. This is what? 40 volt. So what is happening here? This is 2 ohm and this is 2 ohm. So see, uh, without solving this question, we can say that what is the value of charge here, because question asking you the charge in the capacitor across it. So you see this and this is parallel, this and this is parallel. So because BC is parallel to this capacitor. So what will be the voltage across B and C? This same voltage will be across this and this, means same voltage will be across the capacitor. So C is already given in the question. So from here you can find out the charge on the capacitor. So our purpose is to find out the voltage across this end. Okay, so we want to find out voltage across this end, means this is similar to the voltage across B and C. So once we find out the voltage across B and C, we can easily solve these questions. Okay, about the charging problem. So these questions, okay, question about charging on the capacitor. So this is 40 volt, so the 2 ohms, it will equivalent distribute. Okay, so I'm directly writing this is 20 volt and this is 20 volt, this is 20 volt. So basically now voltage across it will be 20 volt. You have to know how to split the voltage across the capacitor. So now voltage across it is 20 volt, capacitance is 20 microfarads. So from here you can find out Q is what? C into V. So C is what? 20 into 10 to the power minus 6 into so you can write in microcoulomb. Okay, 20 into 20. So this is what? 400 microcoulomb. So this is charge at, okay, Q equal to 400 microcoulomb. What about current across BC? So current you can find out easily. Now this 2 ohm and 2 ohm is connected in series. So 2 plus 4 ohm. So I am solving here. So this is 4 ohm. So R equivalent is 4 ohm, and voltage is 40 volt. So current will be what? 40 by 4. So it will be 10 ampere. This 10 ampere current will pass through this and this both. So I have discussed all the possibilities of capacitors. Okay, all the possible questions, okay, which is important for rank point of view. I've discussed everything. Two questions I want to discuss more is that question will ask you this is this is 1 by 2 ohm, and I'm using this like, okay, use it like this, and this is, suppose this is 2 farad, I'm using 2 farad, this is 2 farad, and connected with the battery, okay, with 40 volt, 40 volt battery, it is connected, this circuit, RC circuit is connected to 40 volt. The question is asking you the time after which, after which after which it will charge, it will charge, after which it will charge to uh, half of the maximum value, half of the maximum value, okay, half of the half of the full charging, okay, half of the full charge, half of the full charging. The question asking you the time after which it will be half of the capacitor will be charged simply, okay, half of the capacitor will be charged. So you should know the relation, then only you can solve it. Q equal to Q naught 1 minus e to the power minus ka t by tau. Q equal to Q naught 1 minus e to the power minus ka t by tau. So basically what is happening here, so we need to find out Q is going to be Q naught by 2. So put here Q naught by 2, because we have to find out the time when it will be half charged, okay, half charged. So Q will be Q naught by 2, and it is going to be Q naught, it is going to be Q naught, and it is going to be 1 minus e to the power, we need to find out time and tau. So what is tau here? Tau we need to know, tau is what, R into C. So R is what, 1 by 2 ohm, and you have to keep all the unit in SI unit. So this is 1 by 2 ohm, this is 2 farad, SI unit already given, this is 1. So you have to put out here T by 1. So if you solve it, so you can cancel out Q naught, Q naught. So if you solve it, it will be something come like this, 1 by 2 equal to 1 minus e to the power minus of t, 1 minus e to the power minus of t. I am taking this one this side and this one this side, so it will be like this, e to the power minus of t equal to 1 minus of 1 by 2, 1 minus of 1 by 2. So this will be what, e to the power minus of t equal to 1 by 2. So we can say e to the power minus t is 2 to the power minus 1, okay, yes or no, 2 to the power minus of 1. Now we can take log both side, we can take log both side, ln both side. If I take ln both side, e power minus t equal to ln 2 power minus 1, ln 2 to the power minus 1. So now I will okay, so wait, I'm writing here because I think it's important, so I don't want to erase all this. So if you see ln e to the power minus t, this is 1, so this is what, minus of t, here minus of t equal to ln 2 minus of minus 1 will come this side, minus of ln 2. So here if you still solve, minus minus cancel out, so t equals to ln 2. So I think ln is 0.693, you can check it once, okay, t is 0.693 second, means after 0.693 second it will be half of the capacitor will be charged, half of the capacitor will be charged, half of the capacitor will be, means half of the, I means what is the meaning of this, that okay, it will be half of the capacitor will be charged to the maximum value. So whatever is the maximum value Q naught, so half of that value will be charged to the capacitor, means Q naught of the 2 charge will be on the capacitor. So Q naught of the 2 will be charged on the capacitor. So basically if you want to do you want to play with the capacitor, okay, so basically you have to take care of everything. You have to take care of the series combination, parallel combination, mixed combination, balanced combination, unbalanced combination. You have to know how to distribute charging. In series combination, charging is going to be constant throughout the circuit. In parallel combination, voltage is going to be constant throughout the circuit. If you know all this combination, then it's important. And after this, okay, you should know energy, about energy, that you have to do total energy of U equals to Q into W equal to Q into V. Q is charge on the capacitor, and V is the voltage, okay, is voltage of the source by which you are charging the capacitor. And half of the energy will be dissipated, so full energy will not be stored. So 1 by 2 Q into V energy will be only stored in the capacitor. Other constants comes from there, that I had done that how many plates we require to get equivalent capacity on this. So if you are taking n plates, okay, and connecting alternately, so you will get n minus 1 capacitor, okay, n plate you are getting n minus 1 of capacitor. So again, that is very important relation. If you are connecting to capacitor C1 C2 by the connecting by the voltage B1 and charged up to the voltage maintaining a voltage up to the B1 and B2, so charging up to the voltage b1 and up to the voltage b2. So then a common potential, if you connect both the capacitor with plus to plus, minus to minus, then common potential will be c1 v1 plus c2 b2 divided by c1 plus c2. And if you connect alternate pair plus to minus and minus to plus, in that situation, okay, common potential will be c1 b1 plus c2 b2 divided c1 b1 minus c2 b2 divided by c1 plus c2. But if, okay, suppose capacitor c1 is charged up to the voltage b1 and capacitor c2 is not charged, not connected to the any battery, and okay, means there is no charge on that battery, okay, means that there is voltage across that capacitor 2 is 0, and then you are connecting with the c1, okay, in parallelly, and plus to plus and minus to minus. This sign convention is very very important. In the situation, you, if you want to find out the common potentials, you need to take c1 b1 and c2 b2, that term becomes 0, so you can apply directly formula c1 b1 divided by c1 plus c2. And what is the energy loss if you are charging capacitor c1 to b1, c2 to b2, and connecting both with plus to plus, minus to minus, 1 by 2 c1 c2 divided by c1 plus c2 b1 plus b2 whole square. You can solve all these questions using basic law, basic rules, basic formulas, basic concept as well, but you can also solve all these questions directly. And during charging, capaciting, one capacitor is charging, so q equal to q naught 1 minus e to the power minus t by tau, and after tau time, it will be 0.63% of the capacitor will be charged. So this one here, what is time constant tau here is RC. If you differentiate that equation, it will come I equal to I naught e to the power minus t by tau, so that will give you the current. Okay, at t equals to 0, capacitor will be closed circuit. At t equals to infinity, capacitor will be open circuit. And during discharging, the equation will be q equals to q naught e to the power minus t by tau, and what at after t equals to t tau time, capacitor will be 60 37 30, you can take 37%, okay, so 37% of the capacitor will be discharged. And we have done one question here that, okay, when capacitor will be half of the capacitor will be charged, discharged, and we have done that question, these how to find out the voltage across the capacitor, charge on the capacitor, charge on the capacitor, okay, during this circuits problem. That is very very important. I hope, okay, I explained all the things which is important for you. Till then, thank you.